Hello everyone, myself Kamna Singh, Assistant Professor in Computer Science and Engineering Department, and today we are going to discuss the topic Hardwired Control Unit and Microprogrammed and Instruction Cycle both. And the first thing is that this particular topic is taken by the Computer Organization and Architecture subject. And now first we are going to discuss the control unit. Actually, control unit is a component for the central processing unit. You are, as the name suggests that there is a control unit, it means that there is a all the operations, whatever communication is going on with whatever the hardware components, they are communicating, and this particular control unit will control all the operations. If the control signal will be 0, it means even though all the components will be active for the communication, but their communication will not be taken place. So the control unit, you can say, the controlling all the operations which is going to happen between all the hardware components. These hardware components can be your hard drive or your RAM or a ROM or a CPU or processor or whatever, but the control unit is going to control the signal. Now we are these are the functions of the control unit. These functions are, the first thing is that it interprets the instructions and coordinates the sequence of whatever the input and output is going on, whatever communication is going on. Actually, the control unit signal is 0 or 1. If the control signal is 0, it means whatever communication is going on, this particular signal is 0, it means that communication is not going to take place. And if the control signal is 1, there are only 0 or 1, or you can say 0 is the disable and 1 is the enable value. Whatever communication is taken place, it should be, control signal should be 1. Fine. And control unit also controls many execution units like the ALU or a data registers and the different type of register, MAR, MBR, different type of registers there, and also handles the particular multiple task with a like the multitasking. There is a fetching the instructions, decoding the instruction, reading and executing the instructions. All these is done by the control unit. When we are going to discuss the control unit, actually the control unit designing methods are of two types. The one method is the hardwired control unit, and the next method is the microprogrammed control unit. In the hardwired control unit method means that these are not the types of control unit. These are the hardwired and microprogrammed are actually the designing method, that how this particular control unit is going to design with a hardwired or a microprogrammed control unit. So hardwired control unit is what? Hardwired control unit, when the control unit is going to design with the help of the combinational circuit or a sequential circuit. Combinational circuit like encoder, decoder, or a multiplexer, demultiplexer, these combinational circuit, or a sequential circuit is like flip-flop. So you can say the hardwired control unit, when the control unit is going to design with the help of all these control logics like the multiplexer, demultiplexer, or a flip-flops, or a sequential circuit and a combination circuit, then it is called hardwired control unit. And again, the second method to design the control unit is the microprogrammed control organization. In the microprogrammed control unit, the control unit is going to design with the help of the microprogrammed approach. As you know that what is microprogram? Any operations which is performed in the register, that is called the micro operations. Any type of operations which is performed or executed in the register, that is called the micro operations. And the set of the micro operation, or you can say the group of micro operations, is called the micro instruction. These are called as a micro instructions. And the set of, or you can say the group of micro instruction is called as a micro program. This is called as a microprogram. So you can say that the micro operation, that is the registers. Whatever operations is performed, whatever you are going to add the addition, subtraction, or whatever, all these operations which is performed in the register, that is called the micro operations, and the group of micro operations is called the micro instructions, and the group of micro instructions is called as a microprogram. So the control unit is going to say that this control unit is a microprogram, is taking the microprogrammed approach, then it is called as a microprogrammed control organization. Now, this is the particular diagram for the hardwired control unit. First of all, we have to know that the memory, actually the memory contains the some blocks are there. These are the blocks, and in this particular memory, there is words are there. Some words or a data or information are stored. Whatever blocks are there, these blocks are identified by some specific addresses are there, and these some addresses are called as the physical address. Fine. And suppose that this particular file, suppose any file is executed, f1.txt is stored here, and some addresses there. So MAR register, memory address register. This memory address register contains the currently executed instruction address. Currently executed address, and the one more thing is there is a PC. PC is the program counter, and program counter says that which particular instruction is going to execute it next. So that is the program counter. In this, you can see here there is a instruction register. So the first thing is there, from this whatever instruction is taken place here, this particular MAR instruction is going to the IR. Means memory address register means this MAR is always contain the addresses of the currently executed instruction. And next, this MAR address is going to the instruction register. Instruction register contains the instructions and addresses both. So you can see here there is a 16-bit instruction. This 16-bit instruction is what? There is a in the instruction, this instruction register having this. There is a computer instruction format, that is first thing is mode, and the next is opcode, and the next is address. This is the format of the computer instruction, format of any of the computer instruction. So the mode, opcode and address is there, and the mode is what? Mode can be any of the addressing mode, that is a direct addressing mode or an indirect addressing mode, nothing but. And the opcode is what? Whatever operations you are going to perform in the operand, that is called the opcode. You can see here, suppose that you are opening the file, open file1.txt. So here opcode is the open operation will be there. So whatever operation you are going to perform, that is called the opcode, and the address, whatever currently executed address instruction is there, that is the address. So here you can see there is a 12-bit address. 0 to 11 means there is a 12-bit address is there. Next there is a 3-bit opcode is there, and there is a 1-bit mode is there. You can see here simply that is a 0 to 11 means 12-bit addresses, that is coming from the actually from the memory, and it contains, that is a memory address register to the instruction register. Next, this is the opcode, that is 12, 13, 14, and there is a 1-bit as a mode. This 1-bit suggests there is a mode is there. If I equal to 0, suppose I equal to 0 means that is called as a direct addressing mode. And if I equal to 1, because the I is the single bit value, so you can say I equal to 0 means direct addressing mode, and I equal to 1 means there is a indirect addressing mode is there. So this is called as I. Now in this particular address, this address is coming from the memory address register, and this address is directly goes here in the control logic gates. Fine. And the opcode, suppose that there is a 3-bit opcode. It means what? In the instruction, finally you can use only 2 to the power 3 operation codes are there. Only 2 to the power 3 operations you can perform, or operation codes will be only 8 operations. So by increasing this value, because I have a 16-bit value, so we can convert it into the 3x8 decoder. Decoder is nothing but it is a simple combinational circuit with n input and 2 to the power n outputs will be there. So you can say 3x8 decoder is what? 3-bit values as an input and 8-bit value, that is called as a D0 to D7 as an output of the decoder will goes here as a control logic gates. Next, there is another decoder. There are 2 decoders are there. First one, this is the first decoder, and there is a second decoder is there. This second decoder is what? There is, its size is 4x16. Why it is 4x16? Because there is a 16-bit register is there. So you can say, you know that the output of the decoder is 16. So the input will be what? Because the decoder instruction is, decoder is always like this. Decoder is like this, n into 2 to the power n. N into 2 to the power n means, if I know that the 2 to the power n value, that is 16, it means I can get the input value, that can be a 4, because 2 to the power 4 is the 16. So that's why the decoder size here as a 4x16. Now this 4x16 is going having a timing signal. Means in each tick, in each synchronous communication is going on, all these operations are going to perform with a single tick. There is a 4-bit sequence counter is also there. In the 4-bit sequence counter, there is some values are there. It can be a clear screen or increment or a clock is there. 4-bit sequence counter is taking as an input for the second decoder, and then this goes to the central or a control logic gate. So overall, this is the diagram for the hardwired control unit. Means when the control unit is going to design with the help of the encoder, decoder, multiplexer or a combinational and sequential circuit, then it is called as a hardwired control unit. So this diagram is saying about the hardwired control unit. There is a instruction register, 2 decoders, 1 sequence counter, and the control logic gates. Control logic gates gets the input from the actually opcode, and this opcode is going to the 3x8 decoder, and this is going to the D0 to D7. This input is coming from the sequence counter. Actually, sequence counter gives the input to the second decoder. This decoder is going to the 4x16, and then so that there is a T0 to T15 will be there. So the other inputs is like this. This is the overall concept for the hardwired control unit. Now you can see here for the timing signal, these are the 3x8 decoder and the 4x16 decoder is there. 4-bit sequence counter is there. It means always there is a numbering will be what? T1, T2, T3, T4. Whatever the timing signal is going on, always the timing signal will be T1, T2, T3, T4, because the sequence counter value is 4. Now, the next control unit designing method is the micro-programmed control unit. In the micro-programmed control unit, we can start from here. Control address register. It is also called as a CAR or a control address register. It contains the currently executed address. And the one more thing is there. It is also called as a microprogram sequencer. This is the microprogram sequencer, or you can say that is a next address generator. It is just like the PC or a program counter. Program counter is what? Program counter is finding out the address which is going to the next executed, and microprogram sequencer is also find the address which particular instructions is going to execute it next. So it contains the address of the next instruction. And there is also a control memory. Control memory contains all the data information which is coming from the control address register. And there is a control data register. In this data register, it is also called as a CDR or a control data register. This control data register contains the data or a information. Here in this CAR and the microprogram sequencer, always it contains the addresses. It is also contains the addresses. But in the control data register, it contains the data or a information. So when the control unit is going to design with the help of the microprogramming approach, then it is called as a microprogrammed control unit. And microprogram control unit contains these 4 fields, that is the CAR, CDR, ROM and the microprogram sequencer. Some external input is going on here with the external mapping. There is a microprogram sequencer. Sequencer address is going to the control address register. And then next ROM. ROM contains all the addresses, data and information coming from the external and internal inputs. And next the control data register, and the overall output will be generated as control word. Control word, as you know, that is 14-bit value, and this control word is like this, that is select A, select B, select D and opcode. So whatever the addresses is there, select A, B and D, input, output, these are the 2 operands are there. Select D is the output where the register will be generated, and this is the opcode address. Whatever addition or subtraction or whatever you are doing, that is for the opcode. So you can say this is the 3-bit, 3-bit, 3-bit and this is the 5-bit value. So always the microprogram control unit having the output as control word is there. Whatever information or whatever currently executed instruction, this instruction is going again to the microprogram sequencer, so that you can get the next address which is going to be executed. Now you can see here, that is the microprogram control unit. With this, there is a control. Here the control memory is called as a RAM. It is assumed as. So it is permanently stored all these particular control memory addresses and data, and it contains the control word that specify one or more micro operations for the data processor. The next part is the instruction cycle. So before starting the instruction cycle, we have to understand what are the types of instructions. That is a memory reference instruction, register reference and the input output instructions are there. So the basic computer instructions are, or the types of instruction, first is the memory reference instruction. Again the same format is following, that is a mode, opcode and address. Opcode is of 3-bit, address is of 12-bit and 1 is the mode is there. The first thing, memory reference instruction, how you can finding out that my instruction is the memory reference or a register or a input output instruction, by the help of the opcode. If the opcode is from 000 to 110, then it is a memory reference instruction. If the opcode is 000 to 110, you can say 0 to 6, then it is called as a memory reference instruction. If the opcode is 111, then this particular instruction can be a register reference or an input output. Now you have to check it out, the 15th bit, and this 15th bit or a mode, if the I equal to 0, then the register reference instruction. If the I is 1, then there is a input output instruction. Their question is like this: if I am giving you 1010, if I am giving you this 16-bit instructions, so how you can get that this particular instruction is memory reference or a register reference? So whatever the 12-bit addresses don't matter, you have to finding out this 3-bit, that is the opcode. The opcode is what? This is your opcode. and opcode bit is 010. It lies in this particular. So definitely this instruction lies as memory reference instruction. So you have to finding out that this instruction is the memory reference instruction. So let's start with the instruction cycle. Actually, instruction cycle having these 4 phases are there. There is a fetch the instruction from the memory, then decode the instruction, then read the effective address from the indirect address, and then execute the instruction. This particular instruction cycle you can map with the hardwired control unit. Simply you can see this diagram. In the hardwired control unit, first thing was what? Fetch the instruction. Fetch the instruction from the memory. From this memory, you are fetching the instructions to the instruction register. Fetch the instruction. Then decode the instruction. Here is the decoding the instruction. Then this decoding instruction is reading by the timing signal. Decode and read. And after that, this instruction is going to be executed. So these 4 phases of the instruction cycle you can see here as a fetch the instruction, decode, read and execute. It is simply saying about the hardwired control unit. This is your instruction cycle. I can tell you one by one. First thing, in the instruction cycle, the first thing is what? Fetch the instruction. In the fetch the instruction, actually you are taking from MAR to IR. You are fetching the instruction from memory to instruction register. IR is what? IR having a 16-bit value, and this 16-bit value you can say 0 to 11. So you can see here in the particular instruction, there is a T0, T1 and T2. That is the timing signals. The first thing is what? From the PC, it goes to the AR. So, in the T0 signal, or you can say from here. Next, in the MAR register, means from the memory, that particular instruction is going to the IR, and at the same time, the program counter value will be increased because the next instruction is going to be executed. So, the PC counter will be +1. Next, the next signal is a D0 to D7. This D0 to D7 is coming from where? That from the opcode, and opcode is of the 12 to 14 bit. So, D0 to D7, there is a IR register of 12 to 14 and the AR register is having IR, that is a 0 to 11 and IR 15. This last line you can see easily in this particular diagram, that you can see here. In the IR of 15, IR 15 is what? IR 15 represented as an I opcode. So, you can see IR 15 is a I opcode, simple. Next, you can see IR of 12 to 14. IR of 12 to 14. This is actually what? From 12 to 14 bit. That is as what? D0 to D7. This 3 cross 8 decoder. This 3 cross 8 decoder is going to value generated as a D0 to D7. So, you can write it here simply D0 to D7 as a IR register 12 to 14 bit. And next is a IR of what? IR register of 0 to 11. If the IR is 0 to 11 register, this IR of 0 to 11 bit means what? That is what? That is actually the M of AR. Memory address register will be there. This you can see here, that is the instruction cycle. In the instruction cycle, at the started, there is a sequence counter value is 0. In the first T0, there is a from instruction, from the memory, it goes to the address register. And this address register, MAR, is going to the IR register. And PC value will be incremented. Next, whatever we are discussing here, that is what? The instructions. IR is 15 and IR of 12 to 14 is D0 to D7. This is here. In the decode operation is IR 12 to 14 is going to here. Next, IR 0 to 11 is going to the AR and the IR of 15 as an I as a mode. Now, the next instruction, that you can finding out that the memory reference, this type of instruction is which type, memory reference, register reference, or a input output. So you have to collect with D7. If the D7 is 0, then the memory reference instruction. In the memory reference instruction only we have to get the I mode. If the I mode is 0, it means direct you are not going to collect the data, that is the effective address. And if the I mode is 1, then it goes to the MAR2 address register and you have to calculate the effective address. Fine. And next there is a D7 value is 1. In the D7 value, if the D7 value, you can see here there is a, if the D7 value is 0, so the instruction is definitely memory reference instruction, and you have to check if this is in the case 1. And then you have to check the I value. I value is 0, so direct addressing mode. If the I equal to 1, then indirect. In the second case, if the D7 value is 1, so the two things can be happen. It can be a register reference or a memory or a input output instruction. If register reference means what? Again you have to check the I value. If the I value is 1, so this particular instruction is a IO instruction. If the I value is 0, it means this particular instruction is the register reference instruction. Here it is written over there 0, then register reference, execute the register reference instruction. If the IO is 1, so execute the input output instruction, and then this particular instruction cycle will be going to happen. So this particular diagram will be help to determining the type of instructions. Thank you.